Hello, welcome back to More Fun Fixing It. This one I'm hoping will be a quick repair. Could be famous last words, but let's see. This is another of the ZX Spectrums from the package of dead machines that Paul picked up recently. We've already fixed one of them, and this is the next one that I've picked out of that pile. And it is an issue 3. It's already been recapped. It has a heatsink on the ULA which has been soldered directly to the board. And it has a Murata style switching regulator. So it looks like all the work's been done. There are a couple of logic chips that are missing, and there's a note on here that says color issue, and this is machine number 2. I'm going to take that off. Here. So let's plug it in and see. Oh, it's already had a composite mod done, and with a nice tall cap, but it is done, and we should be able to just plug this in and see what it's doing. I'm going to put my test cartridge in, my Steam Card Pro, because it will show me if any voltages are missing. And we've got nice beeps, good voltages, and a terrible picture. I don't know whether that's just a bad connection. It doesn't feel like it's a bad connection over here, actually. I don't know. Oh, and upper RAM's failed because it hasn't got the logic chips in. I did already dig some out of my parts bin, ready to go. These are 74 HCT 157s, and they're brand new. These are from Retroleum. Oh, that doesn't feel like a very good socket, that one. All right, let's first of all make sure that this passes its tests. And then we can work on this colour issue, see what's going on there, whether it might be something going on over here. Okay, so it is working, and working well. Now, I would like to know what ULA it's got in this one, but I'm not going to pull that off. It looks like it's the thermal compound they've used is not the sort that will give up easily. It's like a silicon. So this doesn't need anything doing to it apart from fixing this colour problem. And we've got no membrane in the top half of the case as well. No membrane at all. Luckily, Paul did actually send some over with these machines to go in, because he knew that some of them were missing membrane, so we can just attach that and make sure that the keyboard is working as it should. All right. It's Christmas at PCB Way. Yes, PCB Way have their new Christmas promotion running, and you can grab some limited first come first served Christmas coupons. You can also get up to 50% off 3D printing and CNC machining, and some incredible deals on PCB prototypes, PCB assembly, advanced PCBs, and whatever FPC rigid flex is. Perhaps the most interesting thing for me in this promotion is a free upgrade to purple, matte black or pink, those most Christmassy of colours, solder masks for your special Christmas projects. You have until my birthday on the 31st of December, I'm sure this was intentional, to fill your Christmas stockings with all of the PCB Way goodies. Link in the description. Merry Christmas, PCB Way. I think I did that with dignity. Well, the first thing I want to do is, this isn't making very good contact in here, because these things, which are only here to stop you seeing through the back of the machine, a silvery bit of modulator can. So that's all that's there for. That's the only reason that's there. It doesn't stop any air or anything getting in or out. In fact, it probably stops a little bit of air getting out. So I don't like them. I want to have a look at what the composite mod looks like inside. Oh, that's not very good. Okay, so you can see, if I zoom you down, that this doesn't go all the way into the socket, because the lead that they've poked through here, they've gone into the center part of this RCA jack, and the pin can't go any further. So I need to move that. I might replace this capacitor actually. That's not the ideal way to do that. It's going to mop up excess solder out of here. Let's see if that, yeah, that's much better. Now that's making a lot better contact. So I'm just going to pop this capacitor out of here because I want to put a smaller one in the way that I like to do it. This one's too big. It's the right value, 100 microfarads, 16 volt is fine. Well, these are a slightly smaller cap, and this allows me to stand it on its end. It just makes a neater kind of way of fitting it. I like to bend the legs around the can like this, and this one out to the side. Pop that into the hole there, and then wangle this other end in here. I find the easiest way to get this out of here, because you need it to come up, is to grab the very end of it with a pair of flush cutters like this, and then pull it straight up. That will give room for the lead coming in to sit where it's supposed to, like that. And just snip this last bit off the end. But that sits on the board quite nicely like that. I just need to solder that in place. I don't think this is the problem. That's my gut instinct here, is this is not the problem. I mean, it could be that that cap was bad for some reason. And it could be bad contact here. Still, not ruled that out yet, but I think something else has gone wrong. I've seen something similar to this before. Right, we need some colour. So let's just pop this in. Yeah. That's definitely still bad. So there is another possibility actually, that the work that was done to this, removing the socket here, caused some trace damage. Because it's the ULA that supplies the colour signal coming out into to the video chip, the LM1889N. It could be a bridge or the uncovered traces on top. Okay, so I'm going to do some investigating and I'll come back. Actually, one thing I want to rule out is these two transistors here at TR1 and TR2. These two are directly in the path of the video signal going straight out of the machine. I don't think that they're anything to do with this. I think it's more around this part of the board. I think it's either the ULA, one of the passives, or TR8 or TR9 a problem here. Looks like there's the signal that's being generated, the color burst signal. Is it the color burst signal? The chrominance. There's like a chrominance and luminance, and also I don't pretend to understand it, but I kind of know of it. That's being generated by these. That used to be on an issue 2, a couple of variable transistors and a couple of variable caps that control things like the dot clock frequency and the color carrier, I seem to recall. But they've been replaced with these two transistors and some other. So there's a couple of capacitors and a resistor down here that are also in that circuit. That all need checking. It could also be this LM1889N has gone faulty. Now, apart from the ULA being taken out, there isn't any other work that's been done to this. But the work that has been done, it looks okay on the backside here. That looks like a neat soldering job and a good cleanup. It's not too bad. But I don't like this side. This side is, especially on this side actually, there's a lot of blobbiness around the solder joints in there. It's very difficult for me to show you that. You can just see down there, there's a lot of solder sitting on there, and the potential for bridges on the top of this board are high because of the uncovered traces, and traces run through between these legs. There's also a couple of traces that I'm not too sure about down here that are coming out, but I think that these ones down this end are to do with the keyboard, so I'm not sure that that's going to be a big problem. But an easy thing and something that I need to do as well is to swap these for BC549s, because this has had a composite mod, a capacitor composite mod. It's sensible to change these capacitors for ones that are going to give a brighter picture. So I'm going to do that now. Now these are different pin out to the original transistors and need to be installed the opposite way from the silk screen markings on the motherboard. So yeah, the other way around. I can't really put it any clearer than that. Right, so that's ruled that out. These are probably fine, but I did need to do that anyway. Okay, so now I need to look at the schematic and find out where the color signals are coming out and where they're going. Right, the thing that I didn't want it to be is the thing I think is the problem, which is the ULA, which is, in this case, a double problem, because not only is it the worst thing to go wrong in a ZX Spectrum, as in it's the most expensive part to replace, it's also, in this one, glued to this heatsink and soldered directly to the board, which is going to make things a bit tricky. Anyway, it might not be the ULA. There might still be a physical problem underneath this chip, but this is what I found out. So I've connected my oscilloscope, which I haven't connected capture, so I'm just going to do that first. Okay, so I've connected my oscilloscope to two ZX Spectrums, and both of these ZX Spectrums are displaying blue screens, completely blue screens. So the paper and the border is blue. And you can see that on the capture. This is the one on the left. This was the Spectrum that I last repaired, the first of this batch of Spectrums. And if we look at the schematic, over here on the ULA, pins 15 and 16 are the red and the blue signals. They're like a balance. I don't really understand it completely. It's the red difference and the blue difference. So U is blue difference and V is red difference. Blue is pin 15 and red is pin 16. Blue is 15, red is 16. So if I look, I've got the blue scope to confuse things even more. I'm going to put it on pin 15 of the working Spectrum. So 19, 18, 17, 16, 15. You can see that trace there is the blue signal. So there's a lot of blue, so you would expect quite a lot of activity. And I'm going to put the yellow one down the side of this ULA onto pin 15 on the broken one. And 19, 18, 17, 16, 15. Now it's difficult to see there. I'm just going to take the blue one away, but that is a very different signal. And these two traces are set up pretty much identically. And because the signal starts at the ULA, there's not much point in me looking further on. I have actually looked around the LM1889N chip, and on pins 2 and 4 where those signals end up is equally a problem. It doesn't look right at that point either. But because the signal comes from the ULA, it could be the LM1889N, and it would be an easier chip to remove. And I did notice in looking around this, I gave this a really good inspection, that the LM1889N has been replaced some time ago. It looks, there's just some slightly messy soldering, and it looks similar to the solder on the ULA. But I think what I should do is remove the ULA and test it in another machine. But what I also think I should do is try replacing the LM1889N first, because it's a smaller chip. They do go wrong, and it could be the problem. I'm really not sure on this one. It would be so easy if this was a standard ZX Spectrum. This was in a socket. I could just pop it out, and then that would be that problem solved. I would know straight away. But now both of these are soldered to the board. What do I do? What do I do? Vote now. And I've done all of the other checks as well, so to making sure that 12 volts is getting to IC14 is the LM1889N. Look, I think I'm going to have to hope that the ULA is okay. We're going to work on the premise that it is. I'm going to remove that capacitor. I'll put it on the other side of the board after the fact. Put it back onto pin 3 from this ground pad or whatever that is there. Yeah, it's ground. I can see where it comes through on this other side. And I'll just put it on the back of the board. I'll put a socket on this side, and we'll try a new chip in there. I'm going to do my usual practice of reflowing all of the pins first, trying to straighten up the all of the pins so that it makes it as easy as possible to take this out. Feels like there's no pin in that bit. They're cut off almost flush. And the thing is with this chip is that a lot of these pads are not connected to anything, quite a lot on this chip. They just weren't used. They weren't needed. So those pads tend to just float away because they're not attached to any trace. They lose all of their strength. So that's a possibility here. It's one of the reasons I might have preferred to take off the ULA instead first. And there are small signs of damage around it. It's little bits of solder mask missing in places around the joint. There's also some of the caps have been replaced. So there's solder mask missing on those, although it does look like they've been flowed with solder, so that's not so bad. There's always the chance that someone did something bad. Let's get that cap off first. Okay, I don't think I lifted any pads, so that's a bonus. I can't wiggle the pins from the other side like I normally would. And there is still quite a lot of solder on the top because it was really blobby, similar to these. There's a lot of solder. I think they reflowed the solder on the top for some reason. So I'm just going to get some foil tape and cover this connector, and then I'll heat it. Ah, okay. Well, that's interesting. I don't think that was me. There's a trace lifted up there. It could well have been me, but there was absolutely no resistance when I lifted that up, and I've done it hundreds of times before. I think that trace had already gone. That trace there. And you can see that there is definitely damage. This is not damage from me. I put no heat into well, not that kind of heat into this side of the board. This has got some signs of previous work. Like I said, the chip had been lifted before, and that's making me worry about what's going on underneath this thing now. We might have some more problems here. That one there, why is that gone? I don't think it's connected to anything. What is that? 20, no, 9, 10, 11, 12, 13, 14, 15. 15, yeah, it is connected. Yeah, it is connected on the other side. 19, 18, 17, 16, 15. Oh, they're all connected together, so that's not so bad. Okay, so which one are we talking about here? 9, 10, 11. 9, 10, 11. That's the one that's lost a trace. No, 10, 11, pin 12. Pin 12 is video input. Video input into the LM1889N might not have been connected properly. So I need to run a bodge wire from there to there on the other side of the board once I've put a socket in. I can't just leave that there because it's just going to short out on that trace there. So I'm going to try and poke it into the hole. It's not solder. I don't think it's going to want to go into that hole. Good, I'm glad that bit came off. I'm just going to put some UV curable solder mask over that floating trace, just to stop it floating around. Can I just say that UV curable stuff is now my new most favourite thing. You'll be seeing some more about UV curable coming up on the channel soon, and let me tell you, it's really exciting as well. So that was just like 30 seconds to cure that. Right, just so I remember, I'm just going to take a photograph. This is the problem one. I'm just going to let the solder flow down that pin, and it might actually make a better connection. If the problem was the connection, then this LM1889 is probably okay. I can try it. I'm going to need to put that cap back, but I am keen to try this. That doesn't tell us anything, does it? It's the same problem there, but I do need to put that cap back. I think that's all right. One more test before I change it. Right, still the same problem. Let's try actually changing the LM1889 for a new one. An actual new one. New old stock, probably. Oh, it's not. So it has to be the ULA. Well, it's late. I need to go to bed now. I'll get up in the morning, have a shave, and I'll take out the ULA. Let's see if there's any problems under there and if it's the ULA itself. But I did have to rule this out. That was the sensible thing to do. And finding that damage under there is making me feel that there is a good chance that it could be some damage underneath the ULA itself. There's all sorts of things that are connected to this circuit that could be a problem. It could be that, it could just be the ULA, and that's the next thing to rule out. So let's go to bed, get a good night's sleep, and come back to this with fresh eyes in the morning. Good night all. Morning. Feeling much better, and I've had my shave. Okay, so let's have another look at this. It's not the LM1889N. The signals coming out of the ULA appear to be dodgy. There is one thing I can try, actually, before I do desolder this, and that's to take the LM1889N chip out and test the signals at this end on pins 2 and 4, which are the red and blue signals that are coming out of the ULA, just to make sure that nothing is causing an issue further down the chain. It would be the same thing as desoldering just the pins on the ULA and testing them in isolation to see if they are causing an issue. But the only thing with this is I'm not going to be able to... oh, actually, I can. I mean, the computer will still work. So I was thinking I wouldn't be able to see an image on the screen because there's not going to be any video output. But that doesn't matter. I can still set the paper and the border to blue and red by typing in the commands using the keyboard. That won't be a problem. Okay, let's do that. Okay, that is now running. If I go border 1, enter, and then paper 1, enter, and then enter again, that should give us an all blue screen. And now I need to fire up my oscilloscope, which takes ages. Okay, so you can see on the capture, that's pin 2. I can't remember what it looked like before. That is pin 4. That's with a blue screen. So if I go border 2, enter, and then paper 2, enter. So pin 4 didn't change at all. I think that's the problem one. So it looks like it is the ULA. I think it's basically now a good idea just to try and get it out. I am going to just try to see if I can just pop this heatsink off. No, I don't think that's going to be possible. I think that is properly glued on there. No, not without damaging the chip. Let's get that out. It looks like these are probably fine just to be desoldered, but I'm just going to give them a little splash of solder on each one. So the person that worked on this, I'm not criticising the work that they've done at all. They seem, you know, there's a couple of bits that underneath that LM1889 that I'm really confident that was not me that lifted that trace. Yeah, I think it was already like that. But that's not to say, you know, I'm confident. That's not to say that's not that the case isn't that. Oh God, I'm really confusing that sentence. It's not to say that it wasn't me. Yeah, there is a chance that it was me, and I could be the cause of some of the problems going on here. but I'm going to be curious to see what's going on under this ULA. So as I'm doing this, I'm conscious of the fact that there's a lot of solder on the other side. I'm probably just going to ignore that for now, because I'm also conscious of the fact that these pads have been through a desoldering process already. So I don't want too much dwell time on each one of these, because that will just lead to more damage. So if there is solder left on the other side, and this is the best desoldering tool I've got at the moment for this sort of work, then hopefully this has dragged it through, and if it hasn't, I'll mop it up with braid. Although it really does look good. I'll mop it up with braid and I'll heat it from the other side and take the chip out that way. Okay, all the pads look intact from this side. Give them a gentle tweak. Yeah, they don't feel like they're moving. Some of them are moving, but not many of them are. I'm going to turn this over, and there's still going to be a good amount of solder on the top side. It's actually not too bad. That's not too bad at all. Right, I'm just going to cover this socket here. Actually, yes. And this crystal, or these crystals here, with some tape. Don't worry too much about anything else. I can replace anything else that gets in the firing line. Right. Station set to 330 degrees. It's moving. Difficult to get underneath it. It's jammed down onto the board. Just going to see if that's actually done enough. Yeah, it's moving there. There's just nowhere to... that's really irritating. I've jammed it right down onto the motherboard. Tempted to heat it from this side actually, and then push down on the pins. Yeah, I'm going to do that. One side's gone. Okay, now the other side's gone. It should be free. Okay, let's see what we've got. What is that? Well, that shouldn't have been there. It's not. There's no legs missing off of the ULA. I wonder if that was causing the issue. This looks, I mean, it looks messy, all of this bit, but this is all just silk screen that's been damaged. There's no actual trace damage that I can see at first glance, which is good. What's that there? Yeah, bits like that look okay. Right, so it could have been that little piece of metal that was laying across a trace or something. Let's get that out of the way. And the thing to do now is to pop this ULA into another spectrum. Once it's cooled down, well, it's still quite hot, and see if it's still working. Use this one again. Let's just check it's still working. Yep. Right, let's get the ULA out of there. Does not want to come out of there. This must be an original socket. Yeah, it's so tight. Okay. Well, we won't know anything until we see some colour. I think this will be okay. No. Oh, it's a shame. What a shame. Okay, so the ULA is dead. Well, not dead, but dead enough. Someone tried to save it. Someone tried to prevent it from going with this heatsink, but I don't think that much thermal glue, whatever that is really going to work. I really want to get that off now. Just going to make sure there's no shorts. Sometimes you can get little bits of solder stuck between the legs, but no, there isn't anything. I am curious if this is going to ever come off. Now that I know it's broken, I can be a bit more brutal. No, I don't think that will. Let's see, do something stupid now. Oh. Carved like a Christmas turkey. Okay, so it's a it's quite an early ULA. It's 6C001E from 1984. And to be fair, I thought, you know, because of this big thick bead of silicon on each side, that would mean there was actually quite a lot of silicon or whatever this thermal compound is in between, which would have been causing this to not actually work as a heatsink, and this would be more of an insulator. But that is quite a thin layer. I'm still not convinced it's really the ideal thing for thermal conductivity though. But sometimes, even no matter what you do, the chip is just going to die. It's just had its time. They have a finite life, these old chips, especially fragile ones like these early-ish ULAs from the first 2 or 3 years of production. And they're just gonna pop eventually, no matter what you do. So I'm kind of the mind of not doing things like desoldering sockets and potentially causing problems. There was a piece of metal underneath there. That could have been just me. Well, that could have been part of anything actually. That could have been me doing this socket, and a piece of metal has flown underneath this part of the chip. But there's always that risk if you take out a socket and solder the chip to the board that you're going to cause some damage. So what I'm going to do is, I mean, this is basically a scrap board now, but it's an issue 3. I quite like these. It's got a switching regulator in it, and it's been recapped, and it's in good condition. So this will likely receive a ULA from something else that is less worthy than this one. So this board will eventually make it back as a working one. It does have a working speaker as well, which this one doesn't. So not all of these are going to make it. This ULA sadly is scrap. But what we need to see now is this one with a socket in and this ULA in there just to test it. That's the next step, and then we can wrap this up. Be hilarious now if this doesn't work. Mustn't forget I'm going to put the original LM1889N chip back in and put that new one back into my stocks, into my parts bins. Make sure that's not on. Put that back as well. Here we go. That looks a bit better. That's working perfectly. I am going to just test after the last one that I fixed where the voltages were all over the place. I just want to check the voltages. I haven't done that on this one yet. Minus 4.67. 12.02. Oh, bang on. And yeah, and 5 volts is 4.95. So the minus 5 volts is a little bit off, but it's often quite far off. So what did I have to do for this one? I had to put 2 logic chips in here. I had to repair the keyboard, and I didn't have to fix LM1889N. I did have to replace the ULA. I'm going to have to take that back out again after I finish this video. I didn't have to do any recapping because it had already been done. I removed this sticker. I wonder if I can get that off. Yeah. Squeaky clean. Yeah, moved the cap onto the back of the LM1889N, tidied up this socket, or replaced that chip with a socket and then put a new chip in it, and changed the slightly messy composite mod. I think that the person that did this work did a good job. I can't criticise what they've done in any way because there was possibly a piece of debris underneath that chip. That might have been me. There was a broken trace under the LM1889N. That probably wasn't a problem. That was probably soldered through, and it may have just been a weakened trace from before when this had been changed, and that could have been me again. It wasn't, but it could have been. So I'm giving the person that did the work on these the benefit of the doubt for now. So far, I think they did a reasonable job. Good recap job as well. All right, let's see what this does. Yeah, made the power move. Speed running Manic Miner. Right, what's my score after that? 1,663. Anyone beat that? For the first level of Manic Miner? So you've got to get it done as quickly as you can to get as much bonus points from the airlift. So 1,663. Leave your score in the comments or post a screenshot. We've got a high score challenge channel in the Retro Hardware Discord. There is a link in the description to the Discord. Come and join. Post your screenshot of this screen, the cold room with your score, and well, I don't think I can be beaten. Right, that's going to annoy so many people. I enjoyed that one. It was a simple fix in the end. Not the result that you really want to see with a ULA being damaged, and I'm going to now take that out. But it is a working machine. I've worked out what was wrong, and we got there in the end. Yeah, there's not much more to say. I do have another 3 of these machines to go and out of this batch. But I think the next one that I fix will be the C64 silver label. I think I need to get that one done. Now that I've got a little bit more, I've got my buffer back. Right, if you like my videos and you'd like to support my channels, come and see me on Patreon and maybe consider taking up a Patreon tier on there. There is a Christmas tier that might still be available by the time you watch this video. For the month of December, you can support me for just £15 for a whole year, and you get a month's worth of videos. I'm probably going to extend that into January now. A month's worth of early access videos, and then it will revert back to like the free tier. But yeah, if you'd like to support at a higher level, even better. All of the support I get from Patreon is super useful to me. There are videos on Patreon explaining my personal circumstances and why this is such an amazing thing for me and for my family. And I really appreciate all of the support, even the people that just watch the videos and comment and engage with me and come to shows and say hello. All of that just makes my life a fantastic thing. Thank you very much for watching. I'll see you in the next one. God, took a long time to get out that one.